Let me tell you something fascinating. Math is everywhere. You may think math is just numbers and formulas, but it's so much more than that. Mathematics is the study of patterns and structures. It's what helps us understand and describe the world around us. From the spiral of a seashell to the way planets move, math provides a framework for making sense of it all. Think about it. When you calculate how long it takes to get somewhere, that's math. When engineers build bridges or scientists predict the weather, they're using math. Even artists use math to create symmetry and perspective in their work.
But where exactly is math? It's all around us. Look at the nature. The arrangement of leaves on a stem follows mathematical patterns. Your favorite apps on your phone, they run on mathematical algorithms. Even the rhythm of your heartbeat can be analyzed with math. And why does this matter? Math helps us organize and predict. It explains why natural phenomena occur and help us control them to our benefit. Without math, we wouldn't have skyscrapers, space travel, or even pizza delivery apps. So, the next time you hear someone say math is boring, remind them it's the key to understand our world. Math isn't just numbers, it is the language of the universe.
Have you ever noticed how the world is filled with patterns? From the smallest snowflakes to the largest galaxy. These patterns are not just beautiful, they're clues to the role that governs our universe. And what about the animals? Take spotted fish like trunkfish and pufferfish, or striped animals like zebras and tigers. These patterns aren't random. They governs by math, explains how cells interact during growth to create these stunning designs. Even natural phenomena shows pattern. Waves in the ocean, ripples in the pond, sand dunes in the deserts, and even typhoons. All of this reveals how water, sand, and air moves in predictable ways, guided by mathematical principles. I don't forget about the animals in motion. Schools of fish swim in a synchronized formation. Geese fly in a V shape to save energy. And starlings create breathtaking tornadoes like murmuration. These behaviors follows mathematical rules that helps the animals survive and thrive. So, patterns in nature are much more than just eye-catching. They are the universe's way of revealing its secrets. From the stars to the seas, from the snowflakes to zebras, math is the language that helps us to decode it all.
Nature is full of incredible patterns, and mathematics is what helps us describe and understand them. These patterns aren't just beautiful, they're efficient and purposeful, revealing the logic behind the natural world. Let's start the symmetry. Symmetry is all about balance and proportion between an object stay the same even after transformation, like reflection, rotation, or scaling. Take bilateral symmetry as an example. It when the left and right side of something are mirror image. You see this in insects like butterflies and animals like cats and even in plants and flowers. Then there's radial symmetry, where symmetry radiates around the central point. Pictures a starfish or daisy flowers. Even is arranged evenly around the center. That's radial symmetry at work. Next, we have fractals. My personal favorite. Fractals are patterns that repeat at every scale, creating self-similar shapes. Think about trees. The branches of the trees resemble smaller version of the whole tree. The same goes for firms. These never-ending patterns are not just mesmerizing but also practical for efficient growth and energy use. And finally, let's talk about spirals. Spirals are everywhere in nature. They're elegant, self-similar curves that focus on a central point. Think of a rose bouquet, a sunflower, or even swirling pattern of a pineapple. These spirals follow mathematical rules and are often linked to growth patterns, making them both functional and stunning. From symmetry to spirals, every pattern in nature has mathematical explanation. These aren't just random, they're the result of efficient arrangement that serve a purpose. Mathematics is what helps us uncover the secrets of this pattern, showing us the logic behind the beauty of the world.
Have you heard of the Fibonacci sequence? It's one of the most amazing patterns in mathematics. The Fibonacci sequence is a series of numbers where each number is the sum of the two that came before it. It starts simple, 0, 1, and then adds up. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, and so on. The sequence goes like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and it just kept growing.
The formula for this is x sub n minus 1 plus x sub n equals x sub n plus 1. X sub n minus 2 plus x sub n minus 1 equals x sub n.
Meaning the nth term is the sum of the two numbers before it. This pattern was named after Fibonacci, also known as Leonardo of Pisa. Back in 1202, he introduced this sequence in his book Liber Abaci, or the Book of Calculation. His fascination with numbers came from his work in the trading industry. One of the best examples of this sequence is the classic rabbit problem. Imagine you start with a single pair of rabbits. Each month, they produce another pair, but only after their second month of life. In month 1, you have one pair. By month 2, still one. But by month 3, they reproduce and you have 2 pairs. By month 4, there are 3 pairs. By month 5, 5 pairs, and so on. The numbers of rabbit pairs follows, you guess it, the Fibonacci sequence. But the Fibonacci sequence isn't just about rabbits. It shows up everywhere in nature. The arrangement of seeds in a sunflower, the spiral of a seashell, and even the way pine cones grow all follow Fibonacci's magic numbers. So, whether it's a colony of rabbits or the beauty of a sunflower, Fibonacci's work reminds us how deeply math is woven into the fabric of life. Isn't that incredible?
Nature, artist, and its masterpiece often follows a fascinating mathematical rule, the golden ratio. This special number, approximately 1.608, appears in so many places in nature that it shows almost magical. Let me show you. First, look at flower petals. Did you know the number of petals on many flowers follows the Fibonacci sequence? For example, lilies have 3 petals. Buttercups have 5, daisies can have 34 or even 55. This is no coincidence, it's the at work. Now let's talk about faces. Yes, even yours, the golden ratio is hidden in facial proportions. The distance between your eyes, nose, and chins form perfect golden sections. This is why some faces are considered natural, beautiful, they align with mathematical balance. But it's not just faces, the human body follows this rule too. We have 5 appendages, 2 arms, 2 legs, and a head. Each hand and foot has 5 fingers or toes. Even the proportions of your limbs are tied to the golden ratio. Animals show similar patterns in their body. The same goes for fruits, vegetables, and trees. Pineapples and cauliflowers and the way branches grow or leaves arrange themselves on a stem. All of these exhibit the golden ratio. Logarithmic spiral, which grows outward in proportion tied to the golden ratio. Even the cochlea in your inner ear and the horns of certain goats follow these patterns. But it doesn't stop there. In the cosmos, spiral galaxies like our Milky Way form beautiful logarithmic spirals at angles of about 12 degrees, and back on Earth, the swirling winds of hurricanes also mirror the Fibonacci spiral. From the smallest flower to the largest galaxy, the golden ratio is a unifying thread, showing us that mathematics isn't just human invention, it's a universal language. Isn't it amazing how math connects everything in the natural world?
Spiral a circular pattern beginning at certain point and circling around the center points as pattern moves outward.
What is mathematics? So mathematics is a field of studies that organizes and discovers abstract objects, methods that are developed for the needs of societies and mathematics.
Fractals are fascinating geometric shapes that experience self-similarity, meaning they reflect that same pattern and different scales. They're found in nature and are also stored in mathematics, revealing complex and beautiful fractals.
Tessellation, also known as tiling, is a fascinating concept that involves covering a surface with geometric shapes without any gaps or overlaps. Is a fundamental concept in geometry and appears in both nature and mathematics, showcasing the beauty and efficiency of repeating patterns.
Symmetry in nature and mathematics is a fundamental concept that describes the balance and harmonious arrangement within a system. It's a recurring theme that manifests in various forms, from intricate patterns of snowflakes to the elegant equations of universe.
Nature is full of patterns and regularities, and mathematics helps us uncover the secrets behind them. From the smallest creatures to vast landscapes, math allows us to predict and understand the behavior of nature. So let's start with honeycombs. Did you know that bees uses math? Their hexagonal cells are the most efficient shape, using the least wax while maximizing strength and storage for honey. Ingenious, isn't it? Now take a look at a zebra's coat. Those beautiful stripes aren't just random. They're a result of mathematical rules that govern how pigments form in the skin. Each stripe is a story of biology and math working together. Speaking of age, have you ever wondered how scientists determine how old a tree is? It is through a dendrochronology, or a tree ring dating. By counting the rings in a tree trunk, we can learn not only its age but also the environmental conditions it grew in. Similarly, turtles have hexagonal growth rings called scutes on their shells, which help estimate their age. Lightning, on the other hand, showcases the beauty of fractals, self-repeating patterns enduring storms. Each bolt splits and branches, forming mesmerizing paths of electricity that demonstrate nature's power. Even something as simple as foam bubble hides a mathematical secret. These bubbles trap gas in a liquid or solid, forming structures that minimize surface area, creating electrical efficiency. Now look closely at train cracks, and you see a mathematical story of stress and weakness over time. Similarly, the sinuous curves of rivers, called meanders, tell us how water flows and shapes the lands over years, analogous of spirals and fractals to the practicality and tessellations, but reveals the underlying nature, whether it is predicting the age of a tree, the behavior of lightning, or the efficiency of honeycombs. Math shows us that the world isn't just beautiful, it's brilliantly calculated. Nature is math in action, and understanding it helps us connect to the world on a deeper level. Mathematics is just not about numbers and equations. It's a force that powers every aspect of our lives, whether we realize it or not. What is behind some of the most significant advancement of the world? Take forensic science, for example. Ever watch a crime show? Calculators helps us enhance blur images and optimize projectile motion, unveiling the mysteries behind every case. In medicine, math plays a life-saving role. Scientists model protein shapes and movements to design drugs that fight diseases. Imagine how many lives are saved thanks to this intersection of math and biology.
Known as tiling. Sakit na. Yeah.
Na nga bata ka.